Hello, Calculus 12 students. Mr. Yoon here. I decided to make a YouTube video clip to help students prepare for the upcoming limits test. Unfortunately, this upcoming week I am a little busy meeting with parents, so I may not have enough time to cover a lot of review material during class. So please watch this video. This video should give you a good idea of the kind of questions to expect for the upcoming limits test. Now, on your limits test, you will have a section on just general theory. So I'm just testing you whether you know your general limit rules. And, question number 1, I'll ask you something like, explain why a limit does not exist. Now, if you want to show that a limit does not exist, basically what you have to do is you need to show me that the left-hand limit does not equal to the right-hand limit. So if you can show me that, that's enough evidence to show that the limit does not exist. So basically what I'm going to do is I'm going to give you some kind of equation here, or not an equation, a limit expression, and you need to show me why this does not exist. And you can do this a few ways. I'll do this 2 ways. Step number 1 is you could draw a graph. All right, so if you have time and if you feel very comfortable with your graphing skills, go ahead and produce a graph. If you've forgotten what this function looks like, you can do a simple table of values to kind of remind yourself, the basic, behavior of this graph here. So just pick some easy numbers like 1, 2, 3, -1, -2, -3. Sorry, that 3 is not very good here, so -3. And then what you want to do is you plug these x values back into your expression right there and find your corresponding y values. Now for a graph like this, if you plug in 1, this is going to be 1 divided by 1. This will be 2 divided by 2, 3 divided by 3. So those will all give you expression of 1. And these guys right here will give you negative numbers, will give you -1, -1, and -1. And if you're at 0, then you're undefined. And that's simply nothing. If you divide by 0, you will have an error. So basically what you want to do here is just, draw the picture of the graph here. So let's call that 1. We'll call this -1. And just draw your graph. And if you want, you can put a little hole there because the graph does not exist at x equals to 0. And now just by looking at your graph here, all you have to do is write a little limit statement when you approach 0 from the left and the right hand side. So x approaches 0 from the right of absolute value of x divided by x. So basically when you're approaching 0 from the right hand side, you are approaching a height of 1. So this equals to 1. And if you're approaching the limit, if you're approaching x from the left hand side of 0 of the graph, approaching from the left hand here, clearly you're approaching a height of -1. Alright, so clearly the left-hand limit and the right-hand limit, they don't equal. So just finish this off by saying that the left-hand limit does not equal to the right-hand limit. Therefore, the limit is x approaches 0 of absolute value of x over x. That will be does not exist. Okay. So there you go. If you have a question like that where I ask you explain why the limit does not exist, you could just produce a graph, write an expression for the right hand limit and the left hand limit, and show that they're not equal, and that would be good enough to get full points for this question. Now, if you don't want to produce a graph, you can definitely use a number line if you feel more comfortable doing that. So another way you can kind of approach this problem is you can do a right hand limit and a left hand limit using a number line. So let me just delete this. Okay, so notice that you're focusing on the x value of 0 there. So once again, just do a little number line here with 0. You have a left hand side and a right hand side. So find some numbers to the left of 0 and find some numbers to the right of 0. And those kind of numbers could be like 0.0001 repeating, and -0.000 repeating with a 1. And all you have to do is insert those numbers into your limit statement. So what you want to do is you want to write a limit statement here as x approaches 0 from the right. And you also want a limit statement when x is approaching 0 from the left hand side. Okay. Now, when you're approaching a 0 from the right-hand side, obviously you're looking at numbers to the right-hand side of 0. So what you want to do is you want to insert that number in here. So this would be 0.000 repeating with the 1, divided by 0.000 repeating with the 1. And you'll notice that the numerator and the denominator are the same, so this will give you a value of 1 here. Now, if you do the same thing with the left-hand limit, when you're approaching 0 from the left-hand side, this would be this number right here, negative 0.00 repeating 1. Once again, just insert that in, divided by the same thing. And since the numerator and sorry, this will be a plus here because that's the absolute value here. So, but overall, the numerator and the denominator, they're the same numerical values, so that will be 1. But since the denominator is negative, this would be a negative 1. So once again, you could just state here that the left-hand limit does not equal to the right-hand limit, therefore your limit does not exist. Okay, so those are two ways where you could show me that a limit does not exist. You can either draw the graph or you can go right to a number line. Now on your real test, I'm simply going to ask you a very similar question. All I'm going to do next is I'm just going to change the function. So I could give you something like 1 over x. Maybe I could give you 1 over x minus 1. Maybe 1 over x plus 2. I could also give you maybe the greatest integer function, or maybe the greatest integer function divided by x. So all I'm going to do for question number 1 is I'm just going to change that limit expression, and you need to show me why the limit does not exist. All right, let's move on to question number 2 now. All right, so for question number 2, I'm going to give you a graph of f of x. All right, so here's f of x. And the question will ask you determine which statements are true or false. If you have a false situation, you need to explain why. All right, so what you want to do is you want to read the statements that are given to you. So if this statement right here highlighted in green is saying the limit as x approaches 0 from the left-hand side is equal to 1. Now, is that true or false? Well, let's focus on this 0 value. Here's 0. Now, if I approach 0 from the left-hand side, I'm approaching a height of 0. So this would be false. I'm not approaching a height of 1. And if it's false, you need to explain why. And all you have to do is just write a limit statement here. As x approaches 0 from the left-hand side of f of x, you are actually approaching a height of 0. Okay, so that's how you would approach these kind of questions. All right, the second question is, as the limit approaches 2 from the left. All right, so where's 2? There's 2. And if I approach 2 from the left, do I approach a height of 0? And the answer is yes, so this would be true. That has a height of 0 right there. From question number C, if I approach 2 from the right-hand side this time, so I'm approaching 2 from the right-hand side, so that means I'm approaching 2 from the right-hand side, do I reach a height of 0? And this one here is false, because if you look to the right-hand side of 2, you don't have a graph. You don't have a graph on the right-hand side of 2, so this is actually does not exist. This would be does not exist because you simply don't have a graph on the right-hand side of 2. Now, if I actually made a graph, if I did a little curve here and did something like that, then absolutely that would be true. If I approach 2 from the right-hand side, I would be approaching a height of 0 if I did have a graph. But for this question, I don't have a graph, so this answer would simply be false. All right, so for question number D, there is a removable discontinuity at x equals to 1. Okay, so x equals to 1, here is 1. You'll notice that at x equals to 1, the left-hand limit does not equal to the right-hand limit. All right, so pretty much you have some kind of a gap here. So in that case, that is not a removable discontinuity. This is actually called a jump discontinuity. All right, so the answer here would be false. You don't have a removable discontinuity at x equals to 1. You have a jump discontinuity at x equals to 1. However, you do have a removable discontinuity at x equals to 0. So at this point right here, because you have a hole there, that would be a removable discontinuity. but whenever you have some kind of a jump or a gap in your graph, we'll call that a jump discontinuity. So for question number D, that's false. All right, so let's move on to some more general theory questions for limits. Now, the last question that you'll have for general theory is I will give you some kind of a limit expression here. So the limit of f of x as x approaches 0 is 3. And then I'll give you another limit expression here. As x goes to 0, g of x equals to -5. I want you to find the following limits. Now for question number 3, you have to write the proper limit expressions. Now on the quiz, I was very lenient. I let some students get away with the limit expressions, but for the actual test, you have to write the proper limit statements. Okay, so for this question down here, you need to write the proper limit statement here. So if I broke this down using proper limit rules, this would be the limit as x approaches 0 of f of x squared plus 3 times the limit as x approaches 0 of g of x. All right, so that's step number 1. You actually have to write that proper limit statement. And after that, you can just insert the numbers and then you should be fine. So this expression right here is simply going to be 3, so 3 squared. And this expression right here, that's simply going to be -5, so this will be 3 times -5, and that will give you a final answer of, that's 9 minus 15, which equals to -6. So that would be full points right there. For the second question, once again, you want to write the proper limit statement. So this is the limit as x approaches 0 of f of x divided by the limit as x approaches 0 of g of x minus the limit of x approaches 0 of 1. All right, so there's your limit statement. And after that, you can just plug in the numbers here. So this right here, the numerator right here, that's going to give you a value of 3. And the denominator right here, that will give you an answer of -5. And this expression right here, there was a very similar question like this on the quiz. This is just simply going to be a constant here. So whenever you have a constant, that limit will simply be its constant. So this will be -1. So this, after you do the math here, this would be This would be 3 over -6, which is -1/2, and that would be considered full points for that question. All right, so that's section 1 of the test. Some just general theory questions with limits. Hopefully you will have little problems with the first 3 questions on the test. All right, now let's move on to some limit questions now. So section number 2 is all about computing limits algebraically. Now, when you're computing limits algebraically, you want to follow a 3-step guideline here. So whenever you have a limit problem where you have to do it algebraically, I would start with direct substitution. I'll call that DS. If direct substitution doesn't work, then you need to apply some sort of algebra. Use your little algebra tricks here. So that means you could factor, or you might have to multiply by the conjugate. And after you apply some algebra and factor or do the conjugate, then you can go back to step number 1 and do a direct substitution. If steps 1 and 2 don't work, then step number 3, I would assume that you probably have some kind of one-sided limit problem. So if you can't do a direct substitution, or if you can't factor or multiply by conjugate, then you probably need to approach the question using the one-sided limit technique, and that means you want to draw a number line and put your your center value in the middle maybe, and evaluate from the left-hand side and the right-hand side. So when you're doing these kind of questions, I would follow the step number 1. If that doesn't work, do step number 2. If that works, go back to step number 1. And if step 1 and 2 don't work, then you want to approach the question as a one-sided limit problem. Okay, let me just get rid of that. All right, so for this question right here, I have the limit as x approaches -3 of x cubed minus 2. Well, this is a simple polynomial, so you just need to use direct substitution here. So I'll write down ds, direct substitution. So this will be -3 cubed minus 2. And when you do that, you should get -27 minus 2, which gives you a final answer of -29. and that would be full points on the test. You don't have to write a limit statement again here. X approaches -3. You don't have to write that step in because simply you're doing a direct substitution, all right? So whenever you're substituting the numbers, you don't have to write the limit statement again. All right, the next question is another direct substitution question here. So for this one, you would just simply just plug in the value of 4 into every value of x. So that'll be 4 plus 4 there. This would be the cube root of 8, and that will give you a final answer of just 2. All right, and that's it. Let's move on now. All right, here's another direct substitution question. One thing that you have to recognize is these brackets here. This is indicating that this is the greatest integer function. So square brackets with x, like that. So we're dealing with the greatest integer function here. Now, if you don't remember how to do the greatest integer function, basically what you're doing is, if you have a number line, you're always routing to the left side of the number line. Okay, so if you have something like 6.2, well, all you want to do is find 6.2 on your number line, and you want to round to the left until you get to the nearest integer. So this works for both positive and negative numbers. So if I'm asking for the greatest integer of 6.2, you always round to the left and go to your nearest integer, and that's going to be 6. And this also works for negative numbers. So if you have negative 6.89, I'm just going to modify my number line here. Let's just say this is negative 6.89, and let's just say that 0 is somewhere over there on the right hand side. Well, the general rule is you always go to the left hand side regardless if you're positive or negative, and the nearest integer to the left hand side would simply be 7. So this is simply going to be negative 7. Okay, so hopefully that will help you with the greatest integer function problems. All right, so let me just erase all this. And for this question, we're just going to do a direct substitution here. So let's just plug in, what that means is whenever I see a whenever I see an x, I change all my x's with -2. So this will be a -2 plus 6 divided by 3 times -2 minus 1 divided by 5. Put that in the brackets. And then you just want to simplify this. This will be a 4 over 3 times -3 over 5. Oops. Put in your brackets there. If you want, you can just cancel those off. That'll be a 1. So this will be a -4 over 5. Okay, so I want to find the greatest integer of -4 divided by 5. So if you go on a number line here, I would say this is roughly going to be -0.8. So if this is -0.8, and if you go to the left, the closest integer value to the left of -0.8, that's going to be -1. So this answer here will simply be -1. All right, let's move on. All right, so your real test will also have a few polynomial expressions here where you have to factor. So for a question like this, if you do a direct substitution, you'll notice that you'll get 0 on the denominator. So if I insert a 3 right away, you'll get 0 on your denominator, so a direct substitution will not work. So you need to go ahead and factor this. So if you factor this, please write your limit statement. So limit as x approaches 3. And the numerator here is going to be x minus 3 and x minus 2. And your denominator will be x plus 3, x minus 3. Okay, and you'll see there that those two expressions will cancel out, and you're left with x minus 2 on the numerator and x plus 3 on the denominator. From here on, you can do a direct substitution step. So this would be 3 minus 2 over 3 plus 3. This will be 1 over 6, final answer. All right, so that question isn't too bad. Just factor, write your proper limit statement, and then you should be all good. All right, let's move on to the next one here. So on your real test, I think I'll probably give you at least 2 factoring questions, and you'll definitely get one question where you have a cube there. So you'll notice that if I do a direct substitution by plugging in 4 for x, I'll get 0 over 0. So I cannot do a direct substitution step here. I need to go ahead and factor this. So let's go ahead and factor this. This is the same thing as the limit as x approaches 4 of x minus 4 divided by, well, I'm just going to rewrite this as x cubed minus 4 to the power of 3. And you should be pretty comfortable with factoring these kind of expressions now. This is the same thing as x minus 4 divided by x minus 4 times x squared plus 4x plus 16. All right, and that's simply coming from the formula that we kind of talked about from chapter number 1. This would be a minus b times a squared minus ab plus b squared. All right, so you just simply use that formula and you should be able to factor the denominator. This is the limit as x approaches 4. And from here on, I can see that this expression, that expression, those expressions will just factor out. And you're just left with a 1 on the numerator, and you have this polynomial expression on the denominator here. And then from here on out, you can just do your direct substitution step now. That means you're plugging in 4 for every value of x. So this is going to be 1 divided by 4 squared plus 4 times 4 plus 16. So I think maybe the hardest part of this question is you actually have to think about this in your head and work that out. This is going to give you a final answer of 1 over 48. Okay. Unfortunately, you can't use your calculators on this test. You have to do everything without your calculator, so sometimes the hardest questions on the test would be computing these numbers. All right, let's move on. All right, so here's a good question here. Once again, if you try a direct substitution for this question, you'll notice that if you plug in 0 for all the x's, you're going to get 0 over, well, this would be a root 3 minus root 3, which gives you 0 over 0. So you'll notice that right away you can't use a direct substitution for this kind of a problem. So if you can't use a direct substitution, you need to multiply by the conjugate, because you have this minus sign there, and you know, factoring does not work. So if factoring does not work, then multiplying by the conjugate would probably be your next best bet. All right, so the conjugate here is simply going to be root x plus 3 plus root 3. So you want to multiply the numerator and the denominator by the conjugate. Okay, now when you're doing one of these kind of problems, let me give you some advice. You only want to simplify the conjugate expression. So what I mean by that is, if you take your denominator and you multiply it by the conjugate, simplifying that is not too hard. In fact, if you simplify the conjugate expression, which is the expression highlighted in blue, you're going to get x plus 3 minus 3. Okay, so when you take a square root and times it by the square root, you'll get x plus 3. And if you take root 3 times, negative root 3 times positive root 3, you're simply just going to get negative 3 on the denominator there. So just simplify the conjugate expression. Now for the numerator, my advice here is don't simplify the numerator, because it's not really like a conjugate times a conjugate, right? So don't simplify the numerator, just leave the numerator as is. Just simplify the denominator only. Okay, now if you take a look at your denominator, you'll notice that I have a plus 3 there and a minus 3 there. So I have x plus 3 minus 3. So the denominator, if you simplify the denominator, you simply just get an x. Okay, and you'll notice that you have an x on the numerator and an x on the denominator, so those can actually just factor out. So you're just left with the limit as x approaches 0 of this expression right here, square root of x plus 3 plus root 3. And from here on, you can do a direct substitution step now. So this would simply be the root of 0 plus 3 plus root 3. And that's going to be root 3 plus root 3, which is going to be 2 root 3. Okay, so for this kind of a question, you can get to the answer very, very quickly as long as you don't simplify certain things in your expression. Only simplify the conjugate expressions because that will give you a very nice answer. Everything else, don't simplify and then just do a direct substitution. All right, let's move on. All right, so for the next problem, we're getting to limits where we approach infinity. So when we're approaching when we have questions where x is approaching infinity, what you want to do is you want to look for the highest power of x in the denominator. All right, so step number one is you want to find the highest power of x in the denominator. And before you can do that, let's just simplify the denominator here. So this is x goes to infinity. The numerator is going to be 3x squared minus 9 divided by, well, this is going to be 9 minus 3x plus 3x minus x squared. All right, so just kind of FOIL the denominator there. And once you FOIL the denominator, you'll notice that we have, we'll get 9 minus x squared. And then what I recommend doing is just rearrange 9 minus x squared into negative x squared plus 9. All right, so for this kind of problem, before you can approach it, just simplify the denominator and just line up your x powers. Now, if you look at the denominator very carefully now, you'll notice that the highest power of x is going to be x squared. All right, so this is the highest power of x in the denominator is x to the power of 2. Now the rule is whenever you have limit problems when x approaches infinity, you're dividing every single term by the highest power of x in the denominator. So let's just do that. This is going to be 3x squared divided by x squared minus 9 over x squared divided by, here's negative x squared plus 9, and I'm going to divide that by x squared. Write my limit statement. X goes to infinity. And those are my highest power of x in the denominator. All right, so from here on, what you want to do next is you want to simplify, and then after you simplify, you want to go to a direct substitution here. Okay, so if we simplify this, this will be the limit as x goes to infinity. Well, that's going to be 3 minus 9 over x squared divided by negative 1 plus 9 over x squared. And when we do a direct substitution here, you'll notice that these fractional expressions, those will just go to 0 and 0, because if you go 9 over infinity, that's the same thing as getting like 1 out of a million on a test, so those will be 0. So once you do that, you're left with 3 divided by minus 1, and your final answer here should be negative 3. All right, let's move on to the next kind of problem. All right, so another problem that you will have to face on the chapter test is when x goes to infinity and you have this square root expression. Now, when you have a square root expression, you want to find the highest power of x in the square root. All right, so you want to find where the square root is. The square root could be on the numerator, it could be on the denominator, it doesn't matter, but what you want to do is you want to find the highest power of x inside the square root. So in this case, if I just focus on the square root sign, I'll notice that x to the power 4 is the highest power of x inside the square root. Okay, so the idea is I want to divide everything, the numerator and I want to divide the numerator and the denominator by the square root of x to the power 4. So let's do that. So this is the limit as x approaches infinity. This is the square root of 5x to the 4 plus 2x, and I'm going to divide that by the square root of x to the power of 4, all divided by x squared, and I'm going to divide x squared by the square root of x to the power of 4. Okay, from now what you have to do is you got to simplify this problem here. So moving on, this is the same thing as the limit as x goes to infinity. The numerator is going to be 5x to the 4 divided by x to the 4 plus 2x divided by x to the power 4. Okay, so simply I'm just using this, in order to get this expression right here, I'm just simply using this limit, this radical property, root a divided by root b is the same thing as root a over b. So if I use that property, that's how I can simplify the numerator. All right, and after that, I'm going to divide that by x squared divided by the square root of x to the power 4. Well, this expression right here, the square root of x to the power 4, that's the same thing as x to the power 4 raised to the power 1/2, which is just x squared. So if I have an x squared here and x squared there, that's simply going to give me a value of just 1. Okay, and then from here on, you can just simplify this expression here. I'm just going to delete this now. And if I look at the x4 here and the x4 there and the x there and the x4 there, I'm simply going to get the limit as x goes to positive infinity of root 5 plus 2 over x cubed. And then now that I've simplified this problem as much as possible, now I can do a direct substitution step here. And if I plug in infinity for this x value on denominator, well, that will simply just go to 0, and I'm left with a final answer of root 5. All right, so that's how you would do one of those limit questions when x is going to infinity when you have a square root involved. All right, so moving on. My next question is another question where the limit is going to infinity, and I have x minus, let me just kind of put brackets around this thing, x minus x to the power 3. Now this question is a little bit different. We haven't seen this question in the homework, and we haven't seen this anywhere else, but we do want to approach this question like how we kind of approach the other questions when x goes to infinity, but we want to set up some kind of fractional, our goal is we want to set up some kind of fractional expression here. Now what you can do is you can factor out an x to the power 3 here, and if you do that, you would get x to the power 3 bracket 1 over x squared minus 1. Alright, so if you're not sure on how I got that expression, basically what you're doing is, if I'm factoring out an x cubed here, what that means is I take everything in the brackets here, I'm basically just dividing by x cubed. So this x cubed is that x cubed right here, and I just simply divide everything by x cubed, and if I do that, I get x, well, if I just simplify that expression right there, I will get 1 over x squared, and x cubed minus x cubed, that's going to be 1, so that's how I get that expression right there. Okay, so that's step number 1. Just factor out an x cubed, and if you factor out an x cubed, you get this expression right here. Now if I do a direct substitution step now, if I plug in infinity into my expression, I get infinity to the power 3 over 1 over infinity squared minus 1. And you'll notice that this expression right here, that just goes to 0. And then I'm just left with, well, infinity to the power 3, I mean, that's still going to be infinity. That's just a big number. And then I'm left with 0 minus 1, which is going to be infinity times negative 1, which will be negative infinity. All right, so for this problem, the answer is negative infinity. And the way you want to approach this question is you want to just factor out the highest power of x, which I did, which is x to the power 3. And once you do that, it's just all algebra from there on. Okay, let's move on to the next one here. Alright, for the next question, notice that I'm no longer approaching infinity. This time I'm approaching x goes to 0. So if I do a direct substitution step here, I get 3 minus 2 over 0 squared, and you'll notice that this will create a problem. So I definitely can't use direct substitution right away. I need to approach this problem using a different method. Now I can't really factor anything. I can't really multiply by conjugate. So if I can't do factoring or a conjugate, and if I can't use direct substitution, this is probably one of those one-sided limit problems. So for a one-sided limit problem, you want to draw a number line, and your number that you're focusing on is 0. So we'll put 0 in the middle there, and then you'll have a left-hand side and a right-hand side. Okay, so for the problem with this kind of question is that you now have to do a left-hand side and a right-hand side in order to get the final answer here. Now for this kind of question, what you could do is you could try to create like one fraction here. So this is 3 divided by 1, and what I'm saying is try to put this together as one fraction. So this will be 3x squared minus 2 divided by x squared. Alright, so what I did there was I was trying to get myself a common denominator. The common denominator will be x squared. So I just take my 3 here and I just multiply that by x squared. Alright, so you might have to do that on the real test. You might have to take your expression and turn it into one fraction. So okay, so now this question looks a little bit easier to approach. Now let's find numbers to the left hand side of 0 and to the right hand side of 0. So a good number that you could use that's on the right hand side of 0 would be 0.000 repeating 1, and a number to the left hand side of 0 could be negative 0.000 repeating 1. And basically what you want to do is you want to plug these numbers into your limit expression. So what I'm going to do here is I'm going to write two separate limit expressions, one when x is going to the right hand side, and I'm also going to write a limit statement when x is going to the left hand side. Alright, so let's do the right hand limit first. Alright, so what that means is I'm going to take this 0.0000 repeating 1 and I'm going to insert that in for my x values. Now, if you take this number and plug that in over here, basically what that means is you're taking 3 times 0.00001, which is the same thing as, well, that's going to be 0, right? 3 times 0.00001 is simply going to be 0. And if you squared it, you'll still get 0. So that's going to be 0 minus 2 over, well, what about the denominator there? If you take this number here and insert that for your denominator, do you get a positive or negative answer? Well, you get a positive answer. And for the numerator, you'll get a negative answer. And a negative divided by a positive, that will give you a negative answer. So that would be negative infinity there. Alright, now if we take a look at the left-hand limit now, what that means is we're going to take this number here in green and we're going to insert that for our x's. You know, same approach. You're definitely going to get a negative value on the numerator because that's going to be 0 minus 2, which is going to be a negative value. And if you plug this negative number into the denominator there, that's going to give you a that'll give you a positive answer there. Because anything, any negative number squared will always give you a positive number. So negative divided by a positive will give you negative infinity. So you'll notice that the right-hand limit and the left-hand limit both give you an answer negative infinity. So the final answer here is going to be negative infinity. All right, let's move on to the next kind of problem that could appear on the chapter test. Now on your chapter test, I might just simply give you a one-sided limit problem. For this question, we're approaching 6 from the right-hand side. So just set up a number line here with 6. So this is this 6 right here, and find a number to the right-hand side of 6. I don't need to find a number to the left-hand side of 6 because I'm just focusing on 6 from the right-hand side. So this could be 6.000 repeating with a 1. And after that, you just want to insert this number into x. So you get you would get 6.000 repeating with a 1 plus 6 divided by 6 minus 6.000 repeating with a 1 there. And from here I can see that my numerator, well, my numerator is going to be positive and my denominator is going to be negative, so my final answer here would be negative infinity. Alright, so that answer, so that question isn't too bad. You just set up a number line and you evaluate this from the right hand side of 6. Alright, let's move on. Alright, now we're getting to trig problems. Now on your test, I'll definitely give you one question where you're involving a trig function, and for this question you definitely have to use this identity from your in-class assignment. So this is the sine x over x, that's going to equal to 1. So on your real test I will give you just one trig function, and for your trig function problem you definitely have to use this identity to help you solve the problem. All right, so our goal is we want to take this expression right here, and we want to our goal is we want to be able to use this identity here. Okay, so we have to apply some algebra here and kind of break the problem up so that we can use our identity there. So what I would do for this kind of problem, what I would do is I would separate this fraction into two separate fractions. So this is sine squared x divided by 3 over 2x squared. Plus x cubed divided by 3 over 2x squared. So that's step number one. Just break the fraction up into two separate fractions. And this expression right here, sine squared x. Sine squared x, this means we're taking our sine and we're multiplying it by itself. So that 2 means, basically that 2 means we need 2 sine x's. Okay, so if we kind of break this up a little bit further here, this would be sine x times sine x divided by, well, basically what I'm going to do next is I'm going to take my denominator there, I'm going to break that up into 3 over 2 times x times x. So x times x will give you x squared, plus this is going to be x over, okay, hold on. Sorry, for this expression right here, the very first thing I would do is I would simplify the x to the power 3 and the x squared, so that will give you an x on the numerator. And this expression right here, 3 divided by 2, that will be 2 over 3. And this is the limit as x goes to 0. Alright, so that's step number one. Just kind of break up the fraction and just kind of simplify each fraction individually. And then after that, you can do the individual limits using your limit rules here. So if I break this up once again, I will get the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of sine x over x. So basically this expression right here is this part right here, and this part in green is going to be that part right there, and this purple 3 divided by 2, what I'm going to do is I'm going to move that to the front now. That's going to be 2 over 3. Okay, and then finally I need to do something for this part of the question right there, so I'm going to write another limit statement plus the limit as x goes to 0 of 2x divided by 3. Okay. Alright, so from here on, you can just tell me the final answer here. I mean, this expression right here, that's going to give you value 1. This right here will give you value 1. And this right here, well, that's just direct substitution, plug in 0, and you'll get a 0 there. So my final answer will be 2/3 times 1 plus 0, which is going to be 2 over 3. Alright, and that's how you would do that problem. Okay, I'm going to do one more problem here, and then I'm going to kind of shut off the video and then start another video for the next part. So the very last question that you'll have for the computing limits section is you'll have more of a complicated problem where you have some square roots and some fractions involved. Now for this kind of a problem, you definitely can't just insert 1 into the problem and be finished, because if you plug in 1 here, you'll get 0 on the denominator. So you definitely can't do a direct substitution. So for a question like this, you're going to have to play around with this until you get an expression where you can use direct substitution. Now, the way I would do this kind of problem is I would focus on the numerator first. And I would want to simplify the numerator. Now, on my numerator, I have these fractional expressions, and look at my denominators there. I have the square root of x plus 3 and 2. What you want to do is you want to get yourself a common denominator. Alright, so your common denominator in this case would simply be 2 times the square root of x plus 3. Okay, so what I'm going to do here is I'm going to take this 2, I'm going to bring that to the top. That's going to be 2. And then I'm going to take my square root here and I'm going to move that to the top. So this will be minus the square root of x plus 3. And then I'll divide that all by 2 times the square root of x plus 3. All right, so that will give me, basically this is my common denominator there, so I can put everything under 2 times the square root of x plus 3, all divided by x minus 1, and then write my limit statement as x goes to 1. Okay, so that's step number 1. You want to look at your numerator, get yourself a common denominator, and once you get a common denominator, you should be able to get this expression right there. Okay, the next step is you want to simplify this entire fraction right there. You want to simplify that. Now, this is pretty much the same thing. If I break this problem down to a simple problem, this would be the same thing as a half divided by a 6. So if I gave you a question like this, a half divided by 6, this is the same thing as 1 over 2 times 6, which is 1 over 12. Okay, so if you didn't see that, this is the same thing as 1/2 divided by 6, which is the same thing as 1 over 2 times 1 over 6, which is 1 over 12. Okay, so if you use your fraction rules, what you can do is you can simplify this complicated fraction here. And if I use my fractional rules, this will be 2 minus square root of x plus 3 divided by 2 times the square root of x plus 3 times x minus 1. Alright, so if I use my fractional rules there, basically the 1 over 2 divided by 6, which is 1 over 12, if I use that little rule here, I can simplify my fraction into this right here. Okay. Now from here on, what can you do next? Well, I can't factor this. I can't use direct substitution yet. So if I can't use those statements, I could definitely multiply by the conjugate, which is another option that you have. All right, so I'm gonna multiply the top and the bottom by the conjugate. So if I take this expression right here, highlighted in yellow, the conjugate of that is simply going to be 2 plus the square root of x plus 3. So I times the top and the bottom by the conjugate. Now this is very similar to one of the problems that we had earlier. When you're multiplying by the conjugate, my best advice is multiply the conjugate expressions only and don't simplify the other parts. So just take your numerator. The numerator you're multiplying by conjugate, so simplify that. So if you multiply those two statements together, well, 2 times 2 is going to be 4. And whenever you have a conjugate, the middle terms cancel out, so you don't have to worry about the middle terms, and just multiply the last terms. So I have a negative here and a positive there, so that's going to be negative, and root x plus 3 times root x plus 3 will simply be x plus 3. Divided by, like I said, don't simplify the denominator because those aren't conjugate expressions, so just leave the denominator alone. And this will be 2 plus the square root of x plus 3. And I'll finish this off by writing my limit statement. Okay. So there you go. I multiplied by my conjugate, and this is what I would get. Now ask yourself, can you simplify the numerator? So if I simplify the numerator, I have 4 minus x minus 3. And this is simply going to be negative x plus 1. And if I have negative x plus 1, I can factor out the minus sign, so this would be x minus 1. So if I simplify the numerator, I just get negative times x minus 1. So what I'm going to do next is I'm just going to delete my numerator here and change that to negative onto x minus 1. And when you do that, you'll notice that I have a common term now, and those can simply just factor out. Okay, so if I do this next, I have the limit as x approaches 1. Now on the numerator, I just have a negative sign, and since nothing's on the numerator, I can just put a 1 there, and this will be 2 times x plus 3 times 2 times the square root of x plus 3 times 2 plus the square root of x plus 3. Okay. Alright, so now that I've done all that, now that I've simplified the problem as much as possible, now I can use a direct substitution step here. So the limit is approaching 1, so whenever you see an x, just replace those x's with a 1. So my final answer here would be negative 1 divided by 2 times 4 times 2 plus 4. And that will give me negative 1 over 2 times 2 is 4. 2 plus root 4 is 2, so 2 plus 2 is 4. So my final answer here will be negative 1 over 16. All right, so that's how you do that question. I will continue the rest of the tutorial on part 2.